All right. Advent of Code day 17. Here we go. There it is, day 17. Man, yesterday was a real doozy. Hoping today will be a little bit smoother. I hope they don't just like continue to ramp up in difficulty, or else I'll be here all day for the next 12 days, or 13 days, 14 days, 17 inclusive, or maybe there's 31 days. I have no idea. That's a good question. We'll find out. All right, so day 17, Conway cubes. Okay, yeah, Game of Life. There we go. I enjoy Game of Life. Okay, as your flight slowly drifts through the sky, do you really want a flight slowly drifting through the sky? I guess you do in this case. The elves at the Mythical Information Bureau, I love this writing, at the North Pole contact you. They'd like some help debugging a malfunctioning experimental energy source aboard one of their super secret imaging satellites. The experimental energy source is based on cutting-edge technology, a set of Conway cubes. Conway cubes. Oh, is this like a 3D Game of Life? Contained in a pocket dimension. When you hear it's having problems, you can't help but agree to take a look. The pocket dimension contains an infinite three-dimensional grid. Yep, at every integer three-dimensional coordinate, there exists a single cube, which is either active or inactive. This is like some weird Christmas Game of Life, the movie cube thing. Do I have to find? Can I only go to prime cubes? Because that would be weird. In the initial state of the pocket dimension, almost all cubes start inactive. The only exception to this is a small flat region of cubes, your puzzle input. A small flat region of cubes. The cubes in this region start in the specified active or inactive state. The energy source then proceeds to boot up by executing 6 cycles. Okay. Each cube only ever considers its neighbors. Any of the 26 other cubes where any of their coordinates differ by at most 1. So, interesting. So yeah, there would be like 9, 9, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 8. Yeah, so that's 18, 26. Yeah, wow. All right. Yeah, given the cube at 1, 2, 3, 2, 2, 2, 0, 2, 3, so on. Okay, during I've just got like the GameCube like stinger cycling in my head right now. I'm just like yeah, okay. During a cycle, all cubes simultaneously change their state according to the following rules. If a cube is active and exactly 2 or 3 of its neighbors are also active, the cube remains active. Okay. Otherwise, the cube becomes inactive. If a cube is inactive, but exactly 3 of its neighbors are active, the cube becomes active. Otherwise, the cube remains inactive. Interesting. Okay, so I mean, this is like Game of Life with a twist. It's gonna be hella hard to visualize. And I guess that's what makes this so challenging. The engineers responsible for this experimental energy source would like you to simulate the pocket dimension and determine what the configuration of cubes should be at the end of the 6-cycle boot process. Wow, okay, so for example, the following initial state. Yeah, this could be computationally expensive pretty fast because it's cubed instead of squared. Okay, even though the pocket dimension is 3-dimensional, this initial state represents a small 2-dimensional slice of it. In particular, this initial state defines a 3 by 3 by 1 region of 3-dimensional space. Okay, so it's like a small plane inside of it. Simulating a few cycles from this initial state produces the following configurations, where the result of each cycle is shown layer by layer at each given z-coordinate, and the frame of view follows the active cells in each cycle. Interesting. So it shows you lower level, regular level, upper level, and then we got more levels, and then we got more levels. Wow, okay. So after 6, we're gonna have 3, 5, 7, 9, 11, 13 deep by probably close to that wide, honestly. After the full 6-cycle boot process completes, 112 cubes are left in the active state. Starting with your given initial configuration, simulate 6 cycles. How many cubes are left in the active state after the 6th cycle? Well, all right. Cool. This I'm not gonna make any predictions about how complicated this will be, because every time I'm like, oh, this seems pretty straightforward, then I spend about 3 hours doing this thing after. So I'm just gonna hold comment. Yeah. So one thing I remember about Game of Life is that the important thing that people always screw up with Game of Life, or the common stumbling block, is that you need to evaluate the entire cycle into a new data space. Like you can't modify the array in place as you're going through it. You need to copy it. It's sort of like how a frame buffer works in video games. Like you make all your changes to this new thing, and then when you're ready, you swap them out, and then you continue and you make changes to this thing, and then you swap them out. So that's a big one. Aside from that, I don't see this working very differently from a regular Game of Life. But I mean, we'll see, because maybe it will. Oh, this is our initial state, so this is going to be input equals, and bam. Okay, and then this is going to be, I guess we can just mark these as plain. I don't think that, I mean, we will probably we'll end up making something at some point that spits out something in this format, maybe minus the Z labels, or maybe with the Z labels. You never know. But in the meantime, I'm going to just mark these as plain. I'm not going to try and capture them. We can just visually inspect them and see if that's what we get. Okay, cool. So we're going to have our usual sections. We're going to have all our definitions, like methods, classes, whatever we end up using. And then we're going to have a section where we test our assertions, and then we're going to have a section where we just run the code. We do this every time. Works for me, so let's keep doing it. Incidentally, Game of Life is like, I really like it as an interview question. Like, I know this is a really polarizing topic, and a lot of companies do interviews, and some will give like take-home tests, and others will get you to whiteboard stuff. And what I found the best one was Game of Life, because it's pretty fast to implement. You can do it in virtually any language. We don't try to be prescriptive about languages. And what I really like about it is even though it's simple and quick, it's just complicated enough that something is likely to go wrong. And during a technical interview, I think that's really the only thing that you want to see. Is you want to see not if someone can do it without it going wrong, because things go wrong all the time. That's part of programming. What's really valuable is seeing how people respond to something going wrong. And it's a great filter, because a really, really high number of interviewees will get maybe like the wrong output, or something will fail to run or compile, and they'll just shut down, and they'll just be like, oh, well, that's what you see what I was going for, and and they'll just like hand wave it away. And those are generally speaking not the people you want to work with. You want to work with the people who work the problem. So like, if I were doing an interview and I was doing Game of Life, I'm hoping for something to go wrong. Otherwise, I'm not seeing what I'm hoping to see. And if the interviewee Googles it, or tries to reason about it, or asks me for help, or any of these things, that's a huge plus. That's a pass in my book. I don't care if they really get it working. Their skill level really ends up informing what types of problems they would work on. But just having that reaction to a problem be try to solve it is exactly who you want to work with. Those are the people you want to end up working with. The people who try to pretend that everything's fine and won't tell you about problems are the people that you typically, in my experience, want to avoid working with. Anyway, let's get started on this. We'll bring in our usual suspects. Login assert. Require assert. All right, so I guess what are we gonna do? We're gonna have a 3-dimensional array. And we could store this as a 3-dimensional array. And it's infinite in every direction. So we could store this as an actual 3-dimensional array, where it's an array within an array within an array times whatever. Or we could, so one of the things we often do is like, we can store the array just as like a, like this, and then we can just choose, we like pretend that it wraps basically. So we could do the same kind of thing here, except it would be like, 10, 11, doing this for space efficiency. This would be 6, what did I do? 4, 5. Oh, I missed 3 here. Okay, 5, 6, 7, 8, 9. So this would be like the, the 10s and then the 20s. Anyway, and the idea here is that you just sort of like mentally accommodate for the width of the array. We won't be able to do that here because it's sort of like an ever expanding map. I mean, we could make the maps very large to accommodate it, but I feel like that's just asking for trouble. So what else can we do? We can do the array of array method, where we have, our one array, and then we've got, so that would be columns, and then we would have rows, and then inside that we would have like the Z index, or maybe it'd be better to have, Z, and then Y, and then X, like that. And then, there'd be just multiple of these, and then multiple of these. So that would be sort of our array. So we could do that. The only problem with using an array is that there's no negative indexes in an array. So what we could do is we could make these objects instead. So we could just have like nested objects. So then we could support negative indexes with objects, because effectively they're just string keys. It might be not as fast to implement, but it might be more ergonomic for us to deal with. And yeah, you know what? I'm gonna go with that. I'm gonna go with, I can't think of a reason not to do this. So let's try it. Our board will be just an object, just a series of nested objects. So where's our input? So this is our input. So this would be, everything here would be Z0. And then we would have Y. I guess what we'll want to do is we'll want to figure out, we probably want to center on this. So this can be Y -1, Y0, Y +1, and then this can be X -1, X0, X +1. So we're going to go Z, Y, X. And we'll refer to the variables in that order just because I feel like that makes the most sense to me, especially when I'm thinking about Y and X. Because when you store it as a 2-dimensional array, typically your y direction comes first. So I try to just keep the y's and the x's in that order in the code. So I'm gonna copy a reference of this down here just so I can think about it. And I'm just gonna comment that out. In fact, I don't need to comment it out. I can just have it as part of the, oh no, this because it's marked down. Okay, so I am gonna comment it out. I guess I could just put it in a plain block. But I really don't, I'm not gonna keep it anyway. Okay, so let's log parse input and see if what we write for parse input does what I just described, which is takes this input and produces our object. Okay, so it's going to be a wall of text coming in, and we're going to do text.split. So we don't really have to deal with the z index here. We can just assume a z of 1, which is nice. So we're going to text split that, and we're going to represent the values. I would just represent the values as trues and falses, because that's what I think. So that would be give us rows. So let's do row. So this would we're splitting on the columns, and then we map on the rows, and then the row see. Oh, this is going to miss an array. Yeah, so this could be, just parsing this might be difficult, but I think it'll pay dividends in later on in allowing us to refer to them negatively. Sounds like I'm deriding them. It's like those dumb arrays, those dumb objects. Okay. Okay, so let's. So this is like my natural instinct is just to split it into an array, but I think what we want to do then is let's continue to split it into an array, and then we will turn that into nested objects after the fact. So we're gonna row split that. Okay, and then we are going to map these val, and then the val is going to be like val is there we go. So if the val is that, there we go. So let's see if parse input gives us that array structure. It does false, true, false, good, false, false, true, 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 true. Okay, so the next thing, now that we've got the array, what we want to do is we want to create our objects. So we want our z object to be this, and it's going to have an index of 0, or it's going to have a property 0, and that property 0 is going to be basically this array as a series of properties on an object. And we want those properties on an object, so we want to refer to this as -1, 0, and then 1. So what we're going to do is we're going to check the length of array. And then, so for, how would we do that? So length, and what we want to do is we want to shift it so we move it by half, but of course we pivot around one thing. Okay, so for row idx in array, what we're going to do is we're going to calculate the offset. I guess offset equals array.length divided by 2, and we're gonna math.floor that. So then the real index here, the new index, is going to be idx minus offset. So I'm just shifting it by half, except one, half minus one, so that it lines up for 0. Okay, so that's our new index. And then what we'll do is we will say z of o equals, and now we need to, because yeah, we're limiting ourselves to the z direction here. So z of o, I mean, we could expand this to take in an arbitrary number of these, but I don't want to do that yet. Maybe we'll have to do that for the next part. So z of o, and then what we're going to do is we're going to go through the rows. Equals, I guess what we need to do is we need to, or equals, and we're going to make a new object with, what is this going to be? New index. Okay, so z of o. So now we need the y. I guess what we can do is we're doing this z of o, or so we've got z. So we've got z. Now what we want to do is we want to add y, and we're gonna add y. So here, so this is going to be y equals. Okay, if y doesn't exist before, y becomes that. Yeah, I'm getting confused already. This is not great. This is not a good sign. Okay, and y of new index is going to equal okay, z of o is gonna or equal to y, so or equal to, okay, and then y's new index property is going to equal this parsed row, excuse me, and we're going to want to parse the row. Okay, so we've got our y. So now for val, and this is going to be the x index. I guess this can be y index. And then this can be new y index. Or I guess we don't need to do that. We can just do this. Just say y index minus off. And this should be y offset. Yeah. Y offset. And then, okay, so for val and x index in row, we're going to initialize this to be our x. So we're also going to have to consider our x offset. These should always be the same, but I'm just gonna be safe. Okay, so val and x index. So I'm gonna want to equals and this is going to be x index x offset equals val. Okay, and then finally we'll return z. Whoops. There you go. So let's see what this gives us back. probably just break. Okay, y can't be assigned because it has not been declared before. Okay, so let's declare it there and declare this there. Right. X. Let's just declare these like this. Okay, so what is this? Cannot read property -1 of undefined. So let's just initialize z, y, and x. So I guess, well, we don't need an x. And what we can actually do is, I've got this backwards, we can do y equals like that. Cannot read property -1 of undefined on line 180. So this would be y. Actually, this would be z, wouldn't it? Maybe I don't need to assign y to anything. And also, I need to set that equal to val. Cannot set property -1 of undefined, and this is line 180 again. Okay, so z, and so I guess here what we'll have to say is z. Okay, so this gives us so z of 0 z0, and then this gives us, or this would be y, and then this would be x. False, true, false, true, true, false, true, true, true. Oh, whoa, weird. Oh, weird. They're out of order. This is going to be real gross. So -1 would be true, false, false. So this is backwards even. Oh my god. So this is okay. So -1 would be false, true, false, and then true. This is going to be super, super gross. Because they are, does negative, maybe negative comes before positive. So let's try that. So these, what I'm hoping to achieve here is sign equals greater than -1, sign equals plus if. So what I'm trying to achieve here is sign equals, there we go. I'd like keys that naturally sort in the same way that the numbers would sort, because this is a super gross part of JavaScript, in my opinion. So I'm going to see if adding a plus sorts these properly. And I'm going to have to do the same thing for x. This is, I should do y sign, y sign, y sign. Oh my god. And then I'll do the same thing for x sign. And then this can be y sign. I mean, this might just not sort properly, but oh yeah, and this should be y sign. But it's worth a try, because if this does work, it'll make my life, whoops, that should be y sign. Should make my life easier. I'm hoping it makes my life easier. X sign X. So let's see what that looks like. So Okay, and I've got a, so this would be +0. Okay, +0, +0. Okay, so this is a very weird order. So in this case, it's just, I think it's just insertion order. Let's try it without that. Okay, so it is, oh, it is just insertion order. So -1, 0. So maybe I don't need these things at all. Yeah, let's try this. Okay. Yeah, no, I do need them. I absolutely need these. Okay, so at least this is going to give us back our items in insertion order, and this will hopefully, or will this will just start screwing up when this will just start screwing up immediately when I start adding to this, because if I add like a -2, it would go on the end, and if I add a +2, it would go after that. So yeah, I don't know what would be a good way. I do wish there was a way that you could do arrays with negative. Let's look it up. JavaScript array negative index. Okay. So yeah, we start from the end. Yeah, there's no such thing as a negative index. Like, what's this? This is interesting. This is interesting. Adds a negative array index to the given array. So unicorn. Oh, is this just a... Oh, it's just to get items backwards from the end. So that's not what I want at all. Okay, so we could continue doing this with these string keys. I don't feel like it's going to work very well. I don't feel like it's going to be very natural. So I guess what we're going to have to do is, I mean, we have an idea of how big this is going to be. So we should just, I mean, what I'm going to do, I'm just going to hard code it. I'm just going to hard code it at a certain value. So let's say 6. So what does this grow by? This is like 1 by 3 by 3. And then the next one would be 3 by 5 by 5. So really we need it to be big enough to accommodate adding to a bunch of times. So it'd be, and the biggest ones are the 3s and the 5s. So we'll start there. So it'd be 3, 5, 7, 9, 11, 13, 15. So this gives us iteration number 7, which is I think where we would end. So we just need it to be bigger than 15. Like, I think this was a fun idea, but I think what we've proven by sort of sketching it out is that it's going to be too complicated, and it's probably just going to lead to more bugs than anything else. So let's give our let's make an input here where we can say this is how many iterations we expect. And then what we'll do is we will grow the original input, which is 2-dimensional, by its size. So what we want is we want target size equals array length. We want this plus 2 times iterations. So this should give us a target size of 15, which is what we just saw. So this is going to, because we can grow 1 in each direction. which is 2 every iteration. So we want to accommodate our current array length plus 2 times the number of iterations. So that's going to be our target size. And just like earlier where we were calculating the offset, so offset, we'll just calculate that here to be math.floor target size divided by 2. So this is going to give us the number of things that we would like to offset. So, and what does that mean when we're done? It means we've got our array and it's going to be 0, 1, 2, 0, 1, 2. And I guess what we would want to do is we'd want row, or I guess we'll want to unshift for I in 0 offset row unshift false, and these are all going to be, there you go. And then we're going to have yeah, we're going to want to do the same thing with text. So let's just do array.unshift. So we're going to add some padding to the left side of the array, and then we're going to do the same thing. We're going to do the same thing to the other side of the array. Array dot. The other thing we could do is we could, whatever, this is fine. And we're going to push. Okay. And then for row in array, we're going to do the same thing here. Oops. Row. And then we're going to return array. And I guess what we'll want to do is actually we'll want to do the same thing for the Z. We're going to want the Z array as well. And what we can do is we can add, let's just create the Z array. Z equals new array with array length. Maybe there's an easier way of doing this. Maybe we can do this pattern, and then we can say Z at offset equals array. And let's return Z. So let's see what this prints. It breaks. Okay. 165 math board target size. What? Oh, 165 array. Oh, there's no array yet. Yeah. Right. Okay. Well, we're not doing it here anyway. Whoops, we're doing it here. Okay. So let's see what we're doing. Row unshift is not a function. Unshift. Array unshift. Row unshift. For row in array, row unshift. What? Okay, let's log array. Let's see what it looks like. So array has a series of rows, and each row is row for row in array. Unshift? Did I spell it right? Row unshift is not a function. What's row here? Log row. Something's weird. Oh, because I'm unshifting false and what? Yeah. Okay. Yeah. So actually, what I think what I want to do is I want to do that last. So this is going to be kind of annoying. I'm going to actually be unshifting an array of target length. Array, new array, and then was it target size? Oh, and this should also be target size. Yeah, and then the default value for that will be false or falsy. It'll be null or undefined. Okay. So maybe this is a better way to do it. Would be to construct the arrays of our target size and then just put the values in their specific places. That might also be a good idea. Okay, so I got all these log arrays, log row. Okay, so 7 empty items, then this with 15 empty items, then false, 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 true, false, 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 true, 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 true. Okay, false, 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 false. Cool. So this, yeah, this looks fine to me. This is at least giving us an array of arrays, a three-dimensional array. Okay. Thank you for watching me for the better part of an hour make a three-dimensional array. What time is it? Oh my God. All right. All right. And now to actual game of life. So this is our board equals parse input input. And let's implement the game of life rules. So, responsible for this experimental energy source. Okay, active. So if cube is active and exactly 2 or 3 of its neighbors are also active, the cube remains active. Otherwise, the cube becomes inactive. Okay, so if a cube is inactive, but exactly 3 of its neighbors are active, then the cube becomes active. So these are our rules, and we're going to, I'm just going to put them right here. Okay. So this is going to be, so we're going to have one cycle, and that's going to take our board, which is an array. And what we're going to do is we're going to clone the board. So new board equals JSON dot parse JSON dot stringify, because we're only dealing with trues and falses here. Board. So this is going to be our new board. And it's going to return a board after one cycle. So for x in new board, for, or not x, for z in new board, for y in z, and for x in y. So we're gonna go through every layer, every column, every row, and then every column in that row. And this is going to give us our Z index. Woo, cat, I'm yelling. Z index, Y index, and X index. Okay, so this is going to give us our Z index, our Y index, and our X index. And what we want to know is we want to permute the values. So for Z offset in -1, +1, and then for y offset, and then for x offset. Jesus. Okay, so what we're doing here is we are looking at the board. So for every piece in the board, we're going to have to look at the 20 some odd square, or 20, what did they say, 26 cubes around it, if they exist. And we are going to keep a counter of active neighbors. Active neighbors equals 0. And active neighbors plus equals to 1 if, well, let's put this if on here. If what do we want? Z or board? If new board, Z index exists, and there's a Y index, and that exists, and there's an X index. So if all of that and X index exists and is truthy, then our active neighbors gets bumped by 1. And so that can be on this line. Okay. Wow, this is getting quite slanty. This is one of the many reasons I love CoffeeScript, is because look at all the closed parentheses or closed bracket braces or brackets I'm not writing. Love my white space sensitive languages. I really should pick up Python. I got into Ruby and I love Ruby, but yeah, it would be nice to have Ruby without all the end keywords. Okay, so active neighbors, and so this is going to tell us how many. See, this is not necessarily. So we've got. So we only want to know about the neighbors, but we don't want to know about continue if. Like, we don't want to know about 0. So here, let's copy. If is 0. So we're gonna skip the 0 case where it's the one that you're looking at. Okay. So this is going to give us the number of active neighbors for this one. And then if active neighbors is exactly 2 or 3 in 2, 3, if active, so if this is going to give us the value. So if X and active neighbors in 2, 3, then the cube remains active. So not then X equals false. Actually, yeah, and then what we need to do is else if exactly 3. So if it's not active and active neighbors is 3, then the cube becomes active. X equals true. Okay, otherwise the cube remains inactive. So is this it? Is this a cycle? Okay, I don't know. Let's try it. Cycle board, and this is going to give us a new board. What we could do is we could make this recursive, and we could just keep calling it iteration times. Or we could do it out here. Let's just do it out here once. So we're going to call, okay, so we got our board, we're gonna log cycle board, and this is gonna give us the next state, and it's going to blow up. 1 minus, oh, whoops. -1. All right, blowing up. Cycle is not defined. there you go, put it on the wrong level. So unexpected indentation, whoops, there we go. Are these in the right level now? Yeah, okay. Cannot read property length of null on 191. So for Z and Z index in new board. On line 191. Yeah, so oh, maybe well, Z is new board. Yeah, oh yeah. Wait, hold on. Log new board. Let's just log the new board and see what it gives us. So nulls, trues, falses. Cannot read property length of null. Should this be, oh, you know what? This should be, yeah, length of null, but this is on line 192. So the problem here is that this should have been new array of target size. Oh, and it's just going to give us a bunch of nulls. And then what we want to do is for layer in Z, we'll say layer equals new array target size. Okay, and then that will give us, apparently not, layer idx, and then we can say Z idx. I guess what we can do is we can say Z dot map layer, and then we can say layer new array. No, we don't need to do that. And then the Z of offset will replace it with array. Nope, still not doing it. So it's still null. So why is that? That's a good question. Oh, you know what? We want new array target size. We also want to map these. Map A to be new array target size. Let's try that. Nope, still not liking it. Okay. Z equals Z map. So it's not destructive. No, still not doing that. I guess what we should do is we should construct these and then populate them rather than doing this like just read them in and then, yeah, so let's do that. So Z equals new array of target size, and then log Z, and then return. So let's just look at this, undefined. So that's interesting. Oh, target size, we don't have a target size yet. So we're gonna grab these first, okay. Then we're gonna grab target size. And we'll grab, okay. So 15 empty items, okay. And that is, what are these? Are we logging? Oh yeah, we're logging these things. We don't need to do that. Board equals parse input board. Okay, so all right, we got our target size. So we're creating those, and then and what we want to do is we want to put Z at offset. So for let's see if we can for layer in Z layer equals new array target size, and we can get rid of these. Okay, 15 empty items. X. So let's try Z index. There we go. Okay. And then that's for layer, and then for row, row index in index. We'll do the same thing here. We'll do Z index R index equals new array target size. And then we'll log Z. And then this will be big. Yeah, so 15, 15, 15, 15. Okay, so what we're gonna do now is we're gonna map over array, and then for row in array, and then for val in row, and this will be row index, and this will be val index. And we can just say when val, and we can say so Z row index plus offset, and then val index plus offset equals true. And then log Z, return Z, sure. Okay, so 15, 15, 15. There we go, we got a true in here, which maps up with this guy, I think. And then, so this is a true followed by 5, and this is a true followed by 6, okay? And then we got true, 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 followed by 5 again, yeah. So perfect. So this is what we wanted to see. I think. So 15 empty items. Oh, maybe not. Maybe we went too deep. Maybe we went too deep with the arrays. Because yeah, it should be a true. Okay, so this is outer, inner. So Z, row offset, and then val index. So this would give us the layer and then the column. Oh yeah, we want to put these all in just offset because it's there we go. And then we get this 8 empty items, then true, then 6, 8 true, 5, 8 true, 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 5. Okay, so or 7 true, true, 5. Okay, perfect. This is finally I think what we want. Okay, and then we can return Z. We can get rid of all this crap. Okay. So what are we doing here? We are parsing the input map, and then figuring out how big to make the board. This is making the blank board. I guess, is it still a board if it's a cube? That's a good question. Yeah. All right. And then populate the active cells. And then return the board. Return the board. Cool. And then, so this is going to be cycle, takes in a board, spits out a board. So now we can log cycle board. So this is going to give us a lot of undefined. So let's look for trues. Oh, man. I always forget you can't search in there. True, true. So this is not making any changes to new board because we're not returning new board. It's just logging the new board. Okay, log cycle board. All right, so let's take it up here and see if it's got more trues than it did before. It does not. Oops. Okay, so we're making a new board. And then what this should be doing is it should be cycling in active neighbors. So let's log active neighbors. So let's log Z index, Y index. Yeah. Let's log these three things, and then active neighbors. Okay. Okay, so it logged a bunch of stuff. It's gonna be extremely difficult to, okay. So that's interesting that it thinks all these have so many active neighbors. Oh no, it's not. These are the indexes. No active neighbors. And then we should start seeing some active neighbors somewhere around like we need to get into the middle of the Z's, which is 8 row, or row 7 maybe, because it's 0 offset. So 7, there we go. 27 active neighbors. That doesn't seem right. No, that's crazy talk. So it should have checked 26 of these, and somehow we're getting 27, and they're all true. If not. And let's, okay, so let's, if active neighbors is greater than 0. If is greater than 0. And then let's not log cycle board. Let's just cycle board. So this is weird that it's giving us 27 active neighbors. And why is that? So Z offset. Z index. Oh my God. Z index plus Z offset. Because it was just looking at itself the whole time. Haha. Z, Y, and X. There we go. That seems more reasonable. And then we don't need to do this not, I don't think. This should still give us the same thing. Okay, so we start seeing active neighbors here. We got a 3. So cool. Yeah, and this will give us new board. And what do we want to know? We want to know the number of active for a board. So let's write that num active, and this takes us a board, which will be array. I just like putting these as type hints. So not cycle. What we want to do is we'll do these things as well. Cool. Where are we? Okay. We will say active equals 0, and then we'll say active plus equals to 1 if I guess we can just say when x active plus equals 1, and then active. So num active for board So how many do we have in our input board? We've got 5 active, right? So we should, let's say log num active board, and then we'll do the same thing after we cycle the board. And we'll see what we get. Reference new board is not defined. Oh yeah, because it's not new board, it's board. Board. Since we're not modifying the board, we don't need to copy it. So we get 5, and then we have 5 active after the fact. That's board. Oh, board equals cycle board. No, still no. And let's try it a couple times. Let's just try it a bunch of times. Yeah, still 5. Well, that's not good. That means that new board oh, okay, because we're just modifying X. What we'll want to do is we'll modify new board. Okay. Okay. Okay, so we'll do that, and this is gonna be true, and then we'll modify new board, send it back. Okay, because this is giving us the right cycles. Okay, so cool. So what do we log? Num active. What are we logging here? We're logging these things. Okay, so we had 5, then we have 14. Is that what they're saying in the thing? Before any cycles, after one cycle. So we got 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's not true. Okay. So after one cycle, it should be, okay, so 3, 6, plus 7, 8, 9, 10, 11. We should have 11. So we should have 11. And then after 2 cycles, we should have a bunch more. So num active starts with 5, and then we should have 11. So we have screwed up one of these rules. So if X and active neighbors not in 2, 3, and active neighbors, you know what, this should be looking at board, not new board. We're making that mistake that I talked about earlier, where we can't modify it in place. We have to look at the old board and write to the new board. So that's probably it, and that's exactly what that was. Okay, ha ha ha. See, even though I warned everyone, including myself, that would happen, it happened anyway. Okay, so what could we do here? We could do cycles num equals 1, and then we could say we could set board equal to that, or let's make an outer function called cycles, and this will just take board and num equals 1, and I guess we can put num in first, say num1 and board, and then for I in 0 up to not including 1, we'll say board equals cycle board, and then we'll return board. Cool. So they want to know, so cycles, let's say 1 board, and just see if it's, oh, see now. Num active, so cycles 1, so we want to do up to and not including 1, 11. Okay, so that's 1 cycle, and we want to do 6 cycles, and oh, num, I do 6 cycles, and it says 71. That seems weird to me. That seems excessively small. I feel like it should be much larger. So let's try 2 is 21, 3 is 50, 4, 5, 6. Oh, that's interesting. It's like the populations are dying and then they're growing again. Oh, that's really interesting. Okay, so 6. So 71 is how many are active. So num active cycles 6 board. And interesting. So we want to assert that 71. Is that what they're telling us to assert? No. After a full 6-cycle boot process completes, 112 cubes are left in the active state. So maybe what we've got is we've got a problem here. Starting with your given initial. So we got to 2 or 1 cycle. That's after 1 cycle. 11 were active. And then how many were active after 2? So I guess we should count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that's true. And after 3 cycles, so assert 11 after 1, assert, we have 21 after 2. And we want to assert that after 6, 112 cubes, and that's not correct. So these are num active. What do you mean num active? Unexpected identifier. Oh, right. Is okay. So these are true, and then let's find out what num active after 3 cycles is. Let's just log it. 50. So we should be able to count 50 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. So 38. So it's not 50. Oh, here's a fun property. Wow, we did a lot of stupid work for nothing. Because, look, the negatives are always a mirror of the positives. So, we could actually have done this without growing our stupid negative indexes at all. We could just mirror them, and then we could just count it twice by using the absolute value. Maybe we'll refactor to that. Man, see, this is why it really it really pays to inspect the input and think about this, because we would have saved ourselves a lot of work. I mean, we'd still have to grow the X and Y, because these are not, the X and the Y don't grow the same way. So we'd still have to do that. Okay. But I mean, we could have added a dimension every iteration to get over this. We could have like unshifted false onto each one. Maybe we'll come back and do that. I don't know. So the first thing I want to know is why after 3 cycles are we getting 50 when we counted 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. So 30 plus 1, 2, 3, 4, 5, 6, 7, 8. We counted 38. And so the third cycle is wrong. So I guess we're gonna have to just what's this? You're overthinking. Print your boards out. Yeah, okay, you're right. You're right, David Jeans. You are correct. I am overthinking. I should print my boards out. Maybe this is a good moment where I should refactor this to use the positive only thing. Yeah, because then the boards that I'm printing will look right. And yeah. Okay, so where's the parse input? So this is just going to figure it out. Okay, so if I have this, then I can just use arrays. And then every cycle, what I can do is I can unshift onto... Oh, then I have to unshift. I don't know. Maybe I'm overthinking this parse input thing. Maybe it should be fine. Maybe I should just make an array printer. David's saying, checking your code so I can have a quick look, please. Okay, sure. What am I doing here? All right. What am I reading? All right. Day 1, part way, check in. Cool. Main push. Wow, these new dialogues in Big Sur are kind of neat. All right. Yeah, David, it is checked in. You can see the problem already. Well, there you are. Okay. I'd love to hear it. What I'd love to do at some point is I'd love to get almost like a Skype thing, and then people can, or a Zoom thing, and then people can consult on screen. That would be really neat because they can consult in real time. At each iteration, you need to consider a board a little bigger on each dimension. Yeah, so what I've done here is I've just made the boards to be as big as they can get. So I parse input with iteration 6, and then so I grow the board to be as big as it could possibly be, which is in this case 6 times 2 plus whatever the current width is, so 15 in every direction. And then what I'm doing is I initialize the board to blanks, and then I populate the active cells considering the offset. At least that's what I think I'm doing, and it seems to be working. And it works for the first iteration, and then the second iteration, but then the third iteration is where it falls over, which is super weird. So it might be the way that I'm calculating active neighbors. So I'm looking in every offset. So a Z offset, a Y offset, and an X offset of -1. So 1 there, 1 there, 1 there. And I skip it if they're all the same. So this is X that I'm looking at. And then I look at the board originally to see if the Z offset plus, or the Z index plus the Z offset, Y index plus the Y offset, plus the X offset. So if these are true, if this is true, then the active neighbors goes up by 1. So maybe what I did is I read the rules wrong. If a cube is active, so if X, so which is the state of the X, in exactly 2 or 3 of its neighbors, and active neighbors, the cube remains active. Otherwise, the cube becomes inactive. Okay, so if it doesn't have exactly 2 or 3 neighbors, then the new board Z, Y, X becomes false. Else, if it is 3, if it's inactive, maybe else if not X and active neighbors is 3. Yeah, this is probably where I screwed up. Nope, still giving me 50. And I'm actually looking for log. Let's do 1. So it should be, yeah, it's 11, 21, 50, and I'm looking for 11, 21, like 30 something, I think. If X and active neighbor is not in new board, yeah, if X and, what is this? If X and active neighbor is not in 2 and 3, then new board is false. I'm setting it equal to false. Yeah. If X and not in 2, 3. So that's what I have. Is that a problem, do you think? Z, Y, X equals false. So this is turning it off if it's on and it doesn't have 2 or 3 neighbors, which is here. So if a cube is active, so that's the if X part, initialize the new board to be blank. So the new board, right, so right now when I initialize the board, it's falsy, so it's undefined. Making the blank board. So I mean, I could do that, array target size, and then I could do for, this is what you're suggesting, I think, for val in row, or for val in, I guess, val index in row. This would be the index. Okay, so I would do v index, these are terrible names, equals false, like that. I cannot read property length of undefined on 184. Here, let's just do in that. So our index v index. Yeah, it's still giving me the same answer. Don't iterate a board in place. The main thing is don't set falses. Set trues onto a blank board. Oh, I see what you're saying. So you want to generate a blank board and then set trues on a blank board. Okay. Yeah, I mean, that's something we could do. So what we'd want to do here is generate, so we'd want to pull out a blank board for target size. So, okay, so let's make this blank board. Blank board. Here, what did we have before? This was Z equals, okay, Z equals blank board target size. And then, we'll just grab this into a blank board array, and then we can iterate over that. I think that's what you're saying. So blank board equals target size. Z equals, and then we'll want to return Z. So this is giving us that. We don't care about offsets. So let's see if this still works. It still works. And then down here in cycle, so instead of making a new board like this, we'll say new board equals blank board dot length, like that. And then so if X, and then if active neighbors into 3, then we want to say new board equals true, like that. I guess you can say and else not X. So this is blowing up. False is true. Because we've got these assertions. Let's get rid of these assertions and see what it gives us. 9, 16, 31. So this is weird. So we have to change, oh, you're saying change the logic to 11, which may have changed now. So if X, oh, that's because we're looking over new board. We want to look over board now. 11, 21, 50. Okay, so this is still working, but it's still giving us the same answers we had before. Which is super weird to me. So let's take a look. Maybe I counted these wrong. So after 2 cycles, 1 cycle, 11, 2 cycles is 21, and then 3 cycles. So we got 5 plus 10, so that's 30, plus 1, 2, 3, 4, 5, 6, 7, 8. So we should be getting 38, and we're getting 50. right? This isn't me being crazy. This is 5 times 2 plus 10 times 2, so that's 30. Unless I didn't change this logic correctly. So if x and active neighbors, then we set the new board to true. It remains true. And then if not x and active neighbors is 3, it becomes true. And then we return the new board. And it's working for the first 2 iterations. So I guess like it's working for 11 and 21, but it's not working for the 3rd iteration, which is 50. Unless, I mean, like, I don't think that their 3rd iteration is wrong. What we could do is we could try to print out some layers and just see what they look like and see where we're making the mistake. So let's print layer, and we'll get a board, and then we'll put in layer, and we'll default the layer to 0. And then this will give us a 2. What's this? Count, S count, 11 count, 21 count, 38 count. Yeah, that's what I'm expecting. 38, and then 58, 101, 112. So where do I go wrong? I guess that's another question. Is 4, 5, 6. Let's find out. Let's see if it just goes 4. Whoops. 5, 6. So what do I? Right. Let's just roll. Oh, there you go. Whoops. So what do I get? I get 11, 21, 50. So I get a 50 where I should have 38, and then 52, 154, 112. So yeah, so mine goes off the rails after the second one, which is super weird. I guess we're gonna need to print these layers. Okay, so 4. That's the layer, and then you know what we can do is we can also pass in an offset equals 0, because this will allow us to push code again. Okay. Where are we? Blank board, target size. The problem is with my else statement. Appreciate the help. Thank you. Just push code again. There we go. It is on its way. I appreciate the help, David. I really do. So while you're looking at that, I'm going to take a look at printing. Just remove the else. Okay. Here. I'm going to remove the else. No, it's still giving me the same. Just remove else. Yeah, that didn't work. If not x and active neighbors is 3. Yeah, if not x. Still, no. Yeah, it's still giving me the same. Okay, I'm gonna continue writing this print layer. Okay, for row in board layer. For so for each row in board layer, so we want to have this offset to just give us a smaller board. When I guess row idx when index is greater than offset and index is greater than offset, index is less than row length minus offset, and then for val in row when same thing, except it's not row length, it's I guess, yeah, it's not row length that I care about here, it's board length, and then row length. So let's, I guess we don't even need to do that, we could just slice it. Yeah, so let's just do that. Let's log row map. So it's going to give us val. If val, then whoops, else dot. So we're gonna map that. So this is gonna be our line equals that map, and then we are going to join it with nothing. And then we're going to log line from offset to negative offset. I think I can do this, and then we can do that. So let's try that print layer. Maybe this calculation board z plus. I don't understand CoffeeScript that well though. So yeah, what is that calculation? So that means so the z index plus the z offset. So the question marks are if it exists, which we might not. Right. So yeah. So why do we have these? So this is in case we get to an edge. I don't think we care about them, honestly. I think this is just going to be this index plus that index plus that index. So I usually put those in if I think we might hit an edge and it might end up being undefined. But it should continue to work. Cannot read property 1 of undefined. So that's, yeah, that's why these are there. So this is, yeah, right, okay, because it is going to check everything. So this is basically, if we get to, you know, like a -1 here, then it means that this is no longer going to be an array, and we can just count that as a false, which would not increase the number of active neighbors. So that's the general idea. It's like the existential access operator. You can do a similar thing in Ruby with like an ampersand. So that's what that is. Okay, I'm gonna try printing the layers. Let's just try printing the layer. Let's try printing a layer board, and then we can remove these logs for now. So we're gonna print layer, and what are the arguments to print layer again? We're layer offset. So we'll do layer 0, whoops, -0, an offset of. So what do we have? 15. Let's try an offset of 6, or let's try an offset of 5, and then the board, and see what this gives us. No, print layer. Oh, that's interesting. So in theory, board should be giving us, oh, print layer, right? It's going to be print layer 7. Yeah, okay, with an offset of 6. No, 5, let's try an offset of 4. Okay, so this is giving us the original input, and I guess our print offset is doing up to not including. Where's print layer? There we go. So log line up to and not including offset. And then when we print the offset of 5, 8, no, 7, 6, no, 5. Okay, so this is giving us, so this is just giving us the offset in the wrong, it's not centered properly. Maybe that's because print layer is doing something wrong when ID is greater than offset and it is less than or equal to, nope, less than, greater than equal to, nope, greater than offset minus 1, oops, nope. Okay, and then log line, yeah, it's offset this way. This is giving us 4. I guess what we really want is 5. Board length minus offset plus 1. Nope, minus 1. It's not happy about either of those. Okay. I guess what we could do is we could do for board layer like that. What just happened? Oh, I forgot log line, offset. So this is definitely, so the offset is 0, so 7 to -7, 6 to -6. I mean, whatever, this is good enough. It's giving us a picture of where things are. So offset to negative offset, so that would be 0 to -0. So what if this was 0 to -0? Yeah, what if I put in an offset of 0? This should give us the whole thing. What about 1 to -1? Yeah, it's weird that it's not centered anymore. Maybe that's part of my problem. Maybe it's not centered and it's going off the side. That would explain, so there's 1, then 2, then 3. Okay, 1, 2, 3, 4, 5. That, I mean, it wouldn't get off the side until later. So iterations. Let's make the target size bigger and see if our 5 or 6 plus. So if we just make the iterations, if we make the target array bigger, then maybe it will delay the time that we had this error. So, and that would explain, no, it's still not. So it's not that, it's not that it's running into the side. So, like even if we go 50 plus, it just takes longer, but it's still giving the same problem. Yeah, this is a tricky one. I mean, this shouldn't be so tricky. I mean, I don't think it should be tricky, because really it's just game of life with an extra dimension. Active neighbors. So this is getting the current, so the current number. Okay. It's not continue versus break, is it? Continue should do the same thing. Should just go to the next iteration. How about unless is 0? Yeah, that does the same thing, but we'll just leave it as unless is 0. So now, what do we have? There, we can just do board. And then, whoops, not that this matters. Whoops, I'm turning my volume up and down. I hope this doesn't affect the stream. Okay. It's weird. It's weird that it works the first couple of times and then it stops working. So like, I feel like we might have like screwed up the rules. Oh, David looks very excited. Okay, he knows z index is y and is 0. Yeah, so that's just saying they're 0 is 0, and you think this is a problem? And y index is 0 and okay, no, that should be z offset. Oh. Wow. Okay. Yeah. So, David, when the pandemic is over, I'm buying you a beer or something. Yes, you're correct. Absolutely. Okay. You get all credit for today. Yeah, there we go. All right. Yeah. Yeah, I thank you for that. It would have been forever for me to find this. Don't need print layer anymore. Don't need to worry about that. Yeah. Okay. David, when we're all vaccinated, I'll buy you something delicious. It doesn't have to be alcoholic, but it can be. So I appreciate it. Thank you. You got one. And as you continue to help, which I'm sure you will, you'll get more. Okay, cool. So that's this, and then 456 we'll check. Boop. So 58, 101, 109. Oh, I think that differs from what you were saying. Yeah, because you were 58, and then 101, 112 was what you had. So I don't know if maybe. And it's certainly not what they're suggesting. So we definitely have more issues. So after 6 cycles, it should be. This is saying it should be 71, because this is what they were saying. No, they were saying 112. Okay, so that has pushed our issue to, and maybe this is the case of we're hitting the edge of the board. So let's try 2 plus that and see. Yeah, now we're getting, so that's exactly what it is. So target size and this assertion error, this is 112 is what they said, right? Yeah, okay. So we did have to expand the size of the board. Okay, so, I feel good about this. So we can assert these, assert 112, good, yes. Okay, and let's log. Oh yeah, we should have input, I guess. Oh, this is just what we wanna log. What are they asking? Oh, get your puzzle input. So this is our puzzle input. And we'll put this input in here. New file. Coffee. Oops. Copy. Module.exports equals. Bam. Is parse input. I mean, we could replace all of these with that, and parse input require input. Whoop. Coming. There you go. And 423. Okay. Let's see. Let's see if that's the correct answer. 423. That's not the right answer. Your answer is too low. Maybe we're not doing the correct number of cycles. Okay, so what are they saying? After the 6th cycle, how many cubes are left after the 6th cycle? Maybe I'm not making the board big enough still. So let's make the board 6 bigger and see if we get the 448. So what about 8? 448. Yeah, so that's our same thing, like array length. So why do I think it can only go 1 bigger than the number of iterations every time? I mean, that makes sense to me. Oh, you know what? Because of the diagonal. 1, 1, 1, 1. So it could theoretically, no, so that should still grow by 1. Let's do iterations times 440 plus array length plus 2 times the iterations. That should cover us, I think. So was it 448 that it's giving us now? And all our assertions are passing. And I don't know what I put in last time, but I think it was small on that. Okay, that's the right answer. 1 gold star closer. Okay, okay, we don't need print layer. This never worked properly anyway, but let's keep it around for right now. Thank you for finding that again, David. I would have been here all night. Let's start day 2. File 2 dot lit, or part 2, not day 2. And okay, let's copy it all. Oh, you never used arrays. Oh, that's interesting. What did you use? I'm curious. If you didn't use arrays, I guess plain. Yeah, I'm curious. Did you use objects? I kind of started by going down the object route with negative indexes and positive indexes as strings, which is probably really bad. Okay, so yeah, I'm just cleaning this up and then we'll read it after a few cycles, after more cycles. Woo, lots of after the full 6 cycle. Okay, so let's read this now. Just used a dictionary and made a string key. Oh, interesting. That's and tracked the bounds. Yeah, you could totally do that. Time proven. Yeah, if it's been working since 2017. Yeah, absolutely. Recycle that code if you can. That's good, because you don't need to use an array. It would make printing the boards probably more difficult. Maybe not actually. And tracking the bounds. Yeah, I guess. Yeah, I mean, really, if you abstract the board into any object and you can ask for a coordinate, it doesn't really matter how you store it. You could store it as arrays, or you could store it as just string keys. Yeah, that's clever. You're okay. Part 2 is super easy, barely an inconvenience. Okay, well, let's hope I prove you right on that. But I appreciate it. Okay, so as your flight slowly drifts through the sky. No, this is part 1. Where's part 2? Part 2. Okay. For some reason, your simulated results don't match what's the experimental energy source engineers expected. Okay. Apparently, the pocket dimension actually has 4 spatial dimensions, not 3. Oh, okay. Well, I'm gonna have to modify this to be 4-dimensional, I guess, and then that's going to affect. So I'm gonna have to, yeah. So for like, see for part 1 here, where I was like doing iterations plus, so this might not work for the next part, but we'll figure that out. Okay, so your pocket dimension contains an infinite 4-dimensional grid. Was this add another dimension, run and done? Okay. It's gonna be, oh man, I do wish I'd made it more modular now instead of doing everything. Okay, each cube only ever considers its neighbors. Is it the same rules? Its neighbors, okay, the initial state of the pocket. Consider the number of active neighbors. So you can go forward or back in time, I guess. That's the idea. For example, consider the same initial state as the example above. Even though the pocket dimension is 4-dimensional, this is initial state. Okay, simulating a few cycles, layer by layer. So they use W. W, X, Y, Z. Okay. Okay, so let's grab our code from this part, and I guess we don't need this here anymore. This there we go. Copy. Let's grab our code and paste it in, and then we'll work at adding another layer. Okay, so this is parse input. So adding another layer. So we did this backwards. We did Z, X, Y, and I guess they're suggesting W. Okay, let's see how bad it'll be. Say W equals, whoops. So everywhere we're using Z. Oh God, there we go. Whoops, blank board. Z offset. I guess we're gonna have, this is gonna be W. Not that it matters what it's named here, but let's name it. So WZXY or WZYX. W offset, Z offset. So blank board, and this is gonna return W. Blank board. It's going to be W, and then we're going to we're going to return W, and this is going to be for time layer index in W. I guess for Z. And what we're going to do is all of these Z's we're going to replace with W, and then we'll say W index. For W index, and then we're going to return W. So this Z equals would be W index. This isn't W index, this is BZ index. Z index. Okay, so for it's going to be for Z, this becomes W. Then we're going to need a W offset. Whoops, not ready yet. Don't run yet. Okay, it's gonna be W offset, and unless W offset, okay. And then, yeah, new board cycles. Num active, this is going to have to be expanded as well for W index in board, and then this is going to in W for, yeah, okay. Do I care about the indexes? I don't think I care about these indexes at all, actually. This is the Y index. There we go. Okay, so for W and board, for Z and W, for Y and Z, for X and Y, when X. Yeah, okay. And what are our assertions? They are for a few cycles. So after one cycle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24, or 23, 26, 29. So 29. Really wish they'd written that down for us. So let's assert 29. And then we'll see if that works. No, it doesn't work. Input is not defined. Oh, right, because we didn't copy it over from the last one. So where is it? Input. And then way up at the top, before any cycles, that's our input. So Z. So right, that's our input. So let's run this. Now, cannot read property length of undefined on 286. All right, here we go. So for layer index in, I guess, yeah. Okay, so false equals true. So, I mean, it ran, which is nice. So let's log the num active there. 0. Num active is 0. So maybe num active is always 0. What if we log the num active of just parse input input? So that's 5. So that's correct. Let's log parse input input and see what we got. Okay, we got, Jesus, we'll only go so many deep. Let's do it of parse input at whatever the offset would be. Okay, so input equals parse input input, and we'll log input input dot length divided by 2 math floor. Okay, and that should give us what our old thing used to be. Holy shit. Okay, so let's just grab that and we'll, whoops, paste it into here and find true. Okay, so we true, 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 true. Yeah, okay. So don't save. Don't save. How do I, there you go. Don't save. So that's interesting. So new board. Oh, because we're not taking in the W offset anymore. And this is going to be W. Okay. And then right, this Z offset. So Z W. Okay. Let's try that. Okay, so text split is not a function. Oh, because I'm rerunning input. Log num active assert 29 takes a while and then fails. Okay, so let's log num active 90. And what are we hoping for? 29. Okay, so this. Okay, so unless W offset is 0, so board W index plus W offsets, Z index plus Z offsets, Y index Y offset, Z X, okay. If X and active neighbors in 2 or 3, new board W Z Y X, if not, new board W Z Y X. And this is giving us a blank board with board length. And I think this is giving us the right size board. Oh, Dave's got more tips for me. Yeah, another dimension running. Okay, can't. 5, 29, 60, 32, 188, 105, 848. Uh-oh. Okay, and line 304 is the problem. Line 304. Look at 304. Look at 304. I will look at 304. 304 for... again. Bam, 29. And that is... Yeah, thank you, David. Okay, that's it. That's 2. It's 2 I owe you now, at least. Okay, and what are we asserting? We're asserting that 29, and okay, I'm going to skip to the end rather than counting all of these, and we want to log num active here. It's going to take a while. Oh yeah, copy and paste is evil. It's always where I run into so many errors. That and not reading properly. That's not the right answer. My answer is too high. Okay, so I flew too close to the sun. Oh, you know what? I also mentioned and then totally ignored the fact that this is probably too small. So let's try iterations time 2 and see if this gives us a different answer. This will take a lot longer to run. Yeah, because like the problem is I guess when you're dealing with another dimension, it will geometrically expand how fast the board can expand. And yeah, wow, like it takes so long to go through these loops. Okay, 7985, but didn't I just say that it was too high? Let's find out. That's not it. My answer is too high. So 7985 is too high. Okay. So let's stop just guessing. Here, I'll, whoops, where is it? Okay, iterations plus. So this would just be the same as 3 times iterations. So I don't know why I'm not doing that. Okay. Okay, so let's actually assert some of these things. So 29, so 60 is after 2. Let's try that. So it's 2. So it's 60. This is like kind of pseudo cheating. Okay, so that failed. Because I don't actually know what these numbers are that I'm asserting. I'm getting them from you, but that's okay. I feel like that's okay. So this is giving me 118. So that's definitely the wrong answer. So it should be 5 after 0. And num active parse input. It should be 5. And these are probably true, and then log num active. And this, I mean, we do want 60, but it's giving us 118. So what is it that we're doing? Are we not turning it off? So blank board length. So blank board Z and W, and then so we make a new array target size. This index should be, this should be the, so that should be the Y index. So really this isn't Z index in W. Okay. So Z index, and then this should be Y X. No. So that's interesting. Maybe I have too many maybe I have too many things here. So for this should be W index in W. No, that's not correct. Z index, and then I make a new Z, and then for, I shouldn't have called this layer. That was just a dumb thing going in. For Y index, Z index, Y index, and then for X index in Y index, and then this is Y index, X index, and then I think this should be false, or new array false. So maybe that's the problem. No, this is blown up now. Assertion false equals true. So we did have, so it's giving us 0. So maybe that was correct. So we've got this new array. So this is the W has this array, then the Z has this array, and then the Y has this array, and then the X. Maybe we do need this array, and for val in X. And then for val in X. No, this doesn't make any sense. I should put it back the way I had it, because it was kind of working. It was working for 5 anyway. Okay, maybe I should just do it, and I should put it back. New array, and for val v index. Yeah, and then w r index. But where's our index coming from? We don't have an r index anymore. It's y. So this is now x index in x index. Let's try that. I feel like this is too many dimensions though, because we've already got an array of that target size. So 118, that's completely wrong. So did we, yeah, are we screwing up this blank board thing? So y index, v index. And what are we logging? We're oh, the number equals 2. So I mean it's working, but it's saying that at 2, so we should go 5, 29, and then 60, and we're not going 5, 29, 60. We're going 5, 29, 118. So that's wrong. I mean, at least our board is being created correctly in theory. I don't know if I need this val index. New array target size. Yeah, I do. Okay. X index. All right. Okay, so W, Z, Y, X. W in board, Z, Y, X, active neighbors. So W offset, Z, Y, X offset, W, Z, Y, X offset is 0. We skip it. Active neighbors. W, Z, Y, X. So if X and active neighbors, if not X and active neighbors is 3. Is it still W, Z, Y, X, W, Z, Y, X? Okay, is it still the same rules? let's take a look. Each cube, okay. Do part 2. For some reason, okay, dimensions, it's a hypercube, which is still either active or inactive. Each cube only ever considers its neighbors. Any of the 80 other cubes where any of their coordinates differ by at most 1. For example, given the cube at x, y, z, w, its neighbors include the cube at, okay? The initial state of the pocket dimension still consists of a small flat region of cubes. Furthermore, the same rules for cycle updating still apply. The same rules still apply. Consider the number of active neighbors of each cube. Given Z and W. After the full 6-cycle boot process completes, 848 cubes are left in the active state. 848. So we wanna assert that 848 is after 6. Cycle 6, and it's not. So this is where it blows out. I mean, it'll blow up at the third one, which should be 60. Yeah. And what are we getting for this log, just out of curiosity? Let's find out. We're getting a very large number. So, I mean, this is usually an indication to me that this is wrong somehow. So if W, Z, Y, X, and we should be oops equals 0, we should be doing, what do they say, your however many neighbors, and we must, I mean, I feel like we must be W, Z, Y, X. So we're doing that unless it is all 0. If, let's break this onto 2 lines. If W, X, Y, W, Z, Y, X, yeah, and active neighbors plus equals 1. So we got loops equals, that's the neighbors considered. And what we want to do is we want to plus equals 1, and then down, oh my god, ha 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 ha, indented the wrong amount. Okay. Wrong loop, brother. Okay, 848 is, we're asserting that, okay. Ha 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 ha. Yeah, you just had to, yeah. I added the new thing, and I indented these and not these. So yeah, and that's what these lines are for. You see these lines here? Should be looking at them, and I'm not looking at them. All right, so let's log. Yeah, we can just not assert that one because we know that it runs. Wow. Okay. This is fun. I like this. This is good. Remember, this reminds me of, this is going to sound trite, but this reminds me of debugging IE back in the day, back when it was like, oh, it must support IE5. So 2400 is the answer that it gave me now. Can I try it? All right, 2400. It's the right answer. Yeah, I remember debugging IE like 5 and stuff back in the day, and IE5 Mac was the worst, and like they were all different, and it was like stuff that just didn't make sense, and you just had to plug through it, and eventually you'd get it, and you'd be like, oh, that's why, because it acts weird in this case, and then oh, it feels so satisfying after. Cool. Okay. Nice. We got it, and I'm gonna leave the assert out just because it takes so long to run, and we're fine with it. But yeah, okay, that was it. Looks around right. Cheers. Thank you, David. Appreciate it. Yen. All right, so we never used these print layers. I'm gonna ditch them. Print. Yeah, we never used print layer. Screw that. Cool tests. These just assert the things. Blank board we used. That was a good suggestion. Thank you. Yeah, good lesson to pay attention. You're right. See you later. Thanks, David. Okay, so parse input. We get the blank board, and we make the blank board here, and then we return the new board. All right. I'm gonna take this off of 2 lines because I feel like it reads better now this way. Okay, and this is gonna be apply the rules, and then we're gonna return the new board. Return the next board. And here, I'll just apply these comments here. So this is apply the rules, turn the new board, turn the next board rather. I guess what we probably could do is we could call this the next board rather than the new board. I feel like that's kind of better. And we'll do the same thing here, new board. Next board. Okay, board equals second board for I num. That's cool. Num active. ZYX, and then num active here is WZYX for W in no, I don't want to. No, I don't know what I did. I'm just curious. I wonder if I can chain these in let's see if this even works. I'm curious. I mean, this is a terrible thing to no. Yeah, unexpected new line. Yeah, I didn't think so. I just wondered if it would work. And it did not, so it's probably for the best. Okay, so got our tests. I like to put a couple of blank lines between these headers. And so tests and run, we'll have them in the blank line there. Okay, so these both still run. I've added just a little bit of comments. Next board equals blank board of board length. Because this is going to be the same in every direction. What we could do to clean this up would be that thing that I mentioned earlier, where we only ever grow the board in one direction. So we actually don't need to do this board length thing at all. We can just grow the board in one direction. And because the states are mirrors of each other, the negative states and the positive states are mirrors of each other, we could just count them twice. I mean, basically. Yeah. We can count them twice unless it's 0. So what would that be like? We can try it. Let's commit what we've got. And this is day. I'm actually extremely hungry right now, but let's push through a little bit. This is day, what is this, day 17? Okay, cool. And we'll push that up. Man, these new modals are weirded me out. I updated to Big Sur last night, and I'm just still getting used to everything. What time is it? I have an iPad here. It's 4:20. I'm very hungry, but I really want to try this. So, but also, you know what? My dog needs to go out. So, what I'm gonna do is I'm gonna come back to this later, and I think I'm gonna do, maybe I'll do a live stream refactor of this later, because it's a really interesting idea. So I'm just gonna leave a note to myself in here, and we'll try it here. And okay, say idea, instead of pre-expanding the board, which was a source of bugs for us. Not a big source of bugs, because I suspected it would be a problem. Let's just assume a mirror above. So above the second dimension. So we're not gonna have, I mean, so that's interesting. So we're still gonna have to expand X and Y, but Z we don't have to expand. Dimension. There we go. Dimension. Dementia is what I have. Let's assume a mirror above the second dimension. So we'll try this next. But for now, I need to eat, and my dog needs to go outside. So thanks, everyone. Thanks especially to David. Huge thanks. I owe you some things, whether they're beer or coffee or whatever you like, when we can safely be near one another again. So of course I have a terrible memory, so you might get nothing, but I'm hoping that I will remember, because I really do appreciate it. All right, so thanks everyone. See you again for day 18 tomorrow, or I guess see you again for what I'll do is I'll record this, and if it works out, then I'll post it as sort of like an addendum, and I'll link it in the usual places. I'll link it in the video. And if it doesn't work out, then I'll probably just mention that I tried it and it didn't work out tomorrow. But cool. All right. See you